Okay? Awesome. Apparently the mic was muted or something, so yes. Yeah. Hi everyone, welcome to Actionable Exceptions. I have the, kind of bad fortune to be the last speaker of the day before the last keynote, so bear with me, or at least try to. I'll try not to bore you too much. If you get bored or whatever, feel free to get a coffee or a beer or something, or just bring beer here. I think I'll be happy to get one. So my name is Avishai Shalom. I'm an engineering manager at Wix. If you've never heard of Wix, then apparently you will never hear about Wix. Yeah, technology. So apparently I had an exception or something. It's right here. And fine, I'll just fall back to old days, old school stuff. Where's the fucking thingy of the thing of the whatever? Yay! Okay, so if you've never heard of Wix, Wix is a $3 billion company. We have about 100 million clients currently, users. We have about 500 microservices. Last time I checked, about 570 developers. Maybe we hired someone in recent days, so I don't know the exact number. We have engineering offices in Israel, in Tel Aviv and Beersheba, in Ukraine, Kiev and Dnipro, and another office in Lithuania, Vilnius, and of course we're hiring, so if you're interested, come talk to me after. But of course, you don't actually care about that. You know, it's all infomercial, blah, 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 very interesting, we've got a lot of scale. Yeah, nobody cares. And this is the part where I'm supposed to introduce myself and explain why you should listen to me. So this is me speaking at some random conference. This is me debugging stuff. This is me designing stuff. This is me writing code, as I always do with Whiskey, because as you know, programmers are a machine that converts Whiskey into code. This is me 5 minutes after I deployed that code. I'm very happy with myself. This is me 20 minutes later, when I saw code running actually in production. This is me in the postmortem, when I found what the hell I did. So yes, lots of fun. Yeah. So, exceptions. Exceptions is a mechanism we use every day, and I think that doesn't get the attention it deserves. This is probably, in my opinion, the most abused mechanism in programming today, specifically in Java and JVM languages. Basically, the reason we need them is because whatever we do, something breaks. Can you actually see this code? So, awesome. So you try to write to a file or do some other kind of obvious action, and something breaks. Maybe you don't have permissions for the file, or maybe the disk isn't working, or maybe you mistyped the file name, or whatever. There's an error. And you have to handle this error. And there are a lot of ways to handle errors. In different languages, we have different ways of handling errors. For example, in C, we have error codes. So a function would return a numeric code, usually an integer, and we would pass that and see, if it's maybe 0, then everything's fine. If it's -1, then something's broken, and we can get the actual cause of the error, usually using some global variable like errno. Again, depends on the API. And the problem with this is that if the return code and the return value of the function is a code, so how do you get data out of the function? So we need some pointer to some mutable struct, and we pre-allocate the struct, and then we mutate that in the function, and we put data in there, and it's really, really ugly, and no one ever checks return codes, and we get horrible bugs. Yes, it was bad. So Go, for example, have something that's a little better. They have multiple return values from functions, and you can actually have return code and the data returned at the same time. So you can actually check that, and that's awesome. But because it's Go and everything has to be simple, of course, they have two error handling mechanisms, because why not? So you have another mechanism, which is called panic, which you can all just assume that breaks and blows up and should shut down your software, your process. But then you can recover from panic using some deferred function, because Go is simple. So of course, we have to have some closure that runs in some place that no one knows about, and yes. So yeah, so we have that. So we have two error handling mechanisms in Go, and it's fine for them, I guess. And then we have the Haskell/Scala style, which is the functional way of dealing with errors. Basically a monad. So we have a function and it returns the error as data. So using either or try, you can actually encapsulate both data and the error in one object. And actually, the monad itself handles the rest of the handling. You don't need to branch out to see if it's an error or not, because the monad actually takes care of that, which is very elegant and I think very, very nice. But unfortunately, if you don't program in Haskell, or if you don't program in Java, and Scala, you don't have that. And even if you program in Scala, often you can't do this because you are actually using Java libraries and they don't support this. Technically, in Java 8, you can actually use functional programming. We have optional, for example, in Java 8, but we don't have a native try monad in Java 8. You can write one yourself. It's not very hard. It takes about 30 to 40 lines of code, but it won't be standard, and a lot of libraries won't support it. And even when Java will finally have a try monad, it will take a very long time before all of the libraries support this. So you can't actually use this in real life, unfortunately. Or you can wrap stuff in it if you want. And then we have the PHP style of handling errors, which is basically just segfault. And you see this and you're like, OK, I want to die. And then you have the closure way of dealing with errors, which is you don't deal with errors because closure is perfect and nothing ever goes wrong in closure. Yes. So, exceptions. Exceptions is another way of dealing with errors, and it's a fairly old way, actually. Exceptions originated from Lisp, because everything actually originated from Lisp. All we do since then is just reinvent stuff that was already in Lisp, but that's really not the point. So exceptions as an error handling mechanism were invented around the 60s, and of course, the first thing that people did with it was to abuse it, of course. They started using exceptions as a kind of a go-to, as a long jump, if you will. Shortly after, about a decade after, we had the catch-throw structure that we know today was invented, and finally arrived a few years after as a way to do cleanup in a safe way. But checked exceptions actually arrived much later. They were introduced by Java in the mid-90s. And to my knowledge, and I may be completely off here, I think it's the only popular language that has checked exceptions. So how does that look? What is checked exception? Checked exception is basically compiler support for verifying that you've actually handled things that could go wrong. So we added a new construct to the method signature, except, of course, arguments and return value. And now the compiler can actually check whether or not you have actually dealt with errors that can happen. Unfortunately, some errors are not checked exceptions, and the compiler can't verify that you've handled them. For example, null pointer exception, or out-of-memory error, and stuff like that. The assumption, or the distinction, is that this is stuff that can actually go wrong anywhere, and there's really nothing you can do about it. A null pointer exception is supposed to be a severe bug, so you have to crash because obviously the code is wrong. And of course, out-of-memory exception, you can't really handle that because to do anything, you would have to allocate memory. So really no point. So the only option is to crash. Now, JVM exceptions. So in the JVM, this is how it works, basically. This is a code block, very nice. We have some method, and that method declares that it throws IO exception. And then we have some other method which calls this method. And basically, when there's an error, it throws an error, okay? We have this construct of try, catch, finally. And in the catch, we get a reference to that exception that was thrown from that method. We can do something with it, maybe report it, maybe recover from it, whatever. And then in the final block, we actually do cleanup. Stuff that needs to happen, whether or not we call the catch block or not, whether it's a success or failure. Do anyone actually recover? That is the question. What do people do with exceptions? So basically, you could do two things. You can use them for debugging, or you can try to recover and continue. Do people actually recover from exceptions? Interesting question. We'll go back to it later. So the way it works in Java is you have a couple of things that happen when you throw an exception. First thing that happens is you create an exception object. An exception object is a class. It's an instance. You have to allocate memory for it. It has a reference in the garbage collection route and everything else, just like any other object. Also collects stack, which we'll talk about in a second. And then you throw it, okay? And when you throw an exception, the method terminates, okay? So when the method terminates, it doesn't actually run the rest of the code. So in this very simple example, the compiler will actually tell you that the rest of the code won't be executed because it's fairly simple to deduce this. But if you have maybe some branching logic there and the exception won't be always thrown, then the compiler can't actually tell you that the code won't be executed. This will only be determined during runtime. Only in runtime you will find that some of the code wasn't executed. Okay? And when an exception is thrown, you jump to some handler, and you execute the handler body, and then after you're done with that, you execute another block of code, which is the finally body, and later an execution resumes from the end of the block. How does that happen? So every function, every method in Java has something called an exception table, and you can see that if you use Java P and you basically dump the bytecode of your classes, you can see this nice table. Basically what you see are offsets of bytecode, and basically it says that from offset 0 to 3, if an IO exception occurs, jump to offset 6. If an exception occurs, on the other hand, jump to offset 14. Okay? So basically every catch handler that you have will appear in the exceptions table with the type of error that it handles. So it's a not very, very sophisticated mechanism. Of course, when you don't actually handle an exception, when you can't find a suitable handler in the exceptions table, then you have to go up. You have to unwind the stack, go to the method to pop the stack frame, go to another frame, and again, look at the exception handler, find a suitable handler, and so on. So actually you do this for every frame in the stack, and if you have 1,000 frames in the stack, you have to go one by one, unwind the entire stack until finally you find some handler and you execute it. Okay? And if that handler really throws an error, the whole process, you do it again, 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 until either you get to the top of the stack or something handled the exception and you don't throw it anymore. So that's basically the mechanism. It's not very sophisticated. Now, what happens if you have arrived to the top of the stack and nothing has handled the exception? So basically, you've got this amazing rules. TLDR, you don't actually care about all of this. Either you install default handler, whether on the thread level or the thread group level or the global level, or the thread terminates. Now, this is a fundamental difference between .NET and JVM. Because in .NET, they've made the design decision to crash the entire process when an exception is uncaught. Whereas in Java, only a single thread is crashed. And you could debate whether or not it's a good decision or it's a bad decision. Personally, I think it's a bad decision. But it's a design decision. It's completely valid. You just know that this is how it behaves. This is the important part. And, of course, that you can tune it, because if you install a handler, then you can always call system exit and basically get to the same behavior. Now, the reason this is important is because you can use this for post-mortem analysis. You can actually write some kind of a crash dump, maybe a thread dump, maybe a heap dump, whatever you want, and you can use that to analyze later what happened and what went wrong in your code. So that's all nice. Why are we having this talk? Because first, I'm really annoyed about exceptions. I don't think anyone is using exceptions properly, including myself, unfortunately, because I write crappy code, but that's really not the point. Exceptions really, really annoy me. And the way people use exceptions really annoy me, and I think it's a horrible mechanism, and people should pay more attention to how they use exceptions, because debugging is actually the thing that we do most of the time. And when you abuse exceptions, debugging becomes so much harder, really, just horrible. So how do people actually use exception? This is from a study, a research that was done. Basically, they did static analysis on 600,000 code repos from GitHub and SourceForge. The majority was from GitHub because, let's face it, nobody uses SourceForge anymore. And these are the top 5 ways that people handle exceptions. You will notice that the most common ways to handle exceptions are to ignore them. What a surprise. So empty block, about 3 million. Nice. Just rethrow the exception. 3.6 million. Awesome. Just log it somewhere, or maybe e.print stack trace. Why, by the way, e.print stack trace is so popular? Anybody who wants to take a guess? Yes, it's the default snippet in IntelliJ. So this diagram actually shows us that IntelliJ is, in fact, the most popular IDE in Java. Yay. And of course, system out println, which you should never, ever do, but I don't know why people do. So that is awesome. There's a reference to the study there if anybody cares. And this is how people, handle exceptions. But this time, this is a check of whether or not the statement is the only thing that you do with an exception. So for example, you would see that about 80% of the times that print stack trace appears, it's the only thing that they do with exceptions. They only print it to stack trace or to println or logging or whatever. They don't do anything else with it. Not a big surprise there. This is from a different study, a qualitative study that was done on 32 very famous code bases in Java and .NET. This is divided by the type of application, and you would notice that the majority, especially in server code, of ways of handling code is either logging, rethrowing, or doing nothing. Okay? The others, where you actually do something, or alternative config, where you actually do something with an exception, is a negligible minority on this histogram. So apparently, people don't actually handle errors. And what do people catch? I mean, we have this fancy tree of inheritance of exception types. This inherits from exception, and IO exception inherits from exception, then you can inherit from IO exception, blah, blah, blah. In fact, people catch exception, they catch throwable, and this accounts for about 40% of the stuff that people catch, and the rest of the stuff is SQL exception and IO exception. And that's about it. Okay? Only generic exception handlers. This is what people actually do in practice with exceptions. So this is a quote from one of the studies. Furthermore, developers tend to wrap checked exceptions inside checked ones while throwing them back to the caller. And by this, they defeat the mechanism of checked exceptions because the compiler can no longer check that you've actually handled the exception. Which begs the question, if we're circumventing the whole checked exception mechanism, why do we even have it? I don't know. This is from another study. In general, exceptions are not being correctly used, blah, 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 symptom of a serious design flaw in the mechanism. Blah, 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 not fully appropriate for handling application errors. Now, we as a community have voted in an amazing majority that we don't care about this. As a community, we have decided that we don't like exception handling, we don't like this whole construct, we just ignore it, or we abuse it, or we work around it in some weird way. So, I don't know. Like, this is the facts, I guess. So, just a short recap. What people actually do, first of all, they prefer logging to recovering, and this is also my experience. Nobody recovers from errors, almost never. Handling code if it exists, it's very sparse and generic, always catches exception, and then you can't actually recover, of course, because you don't know what went wrong. Exceptions are often ignored or swallowed. Again, not the big surprise there. And checked exceptions are treated as an annoyance, which explains the popularity of languages like Scala, which completely erased the whole mechanism because apparently nobody likes it. So, okay, but what's the problem really? And there are a lot of problems with exceptions. First of all, it creates a lot of telemetry noise, which makes debugging so much harder. It creates confusing control flow, a lot of problems in code maintenance, a lot of bugs, and of course, performance issues. This is from an actual application that I had the honor of working on. I didn't write the entire code base, but this is from an actual production system. Now, I didn't put the error percentage here, but every 30 seconds, about 3,000 exceptions appear in the logs. This is not the number of exceptions that are actually generated in the JVM, only the ones that are actually logged. Okay? 3,000 exceptions every 30 seconds, and this is pretty much it accounted for about 99% of our logs. 99% of the logs was just errors. So, newsflash. Exceptions, by definition, are exceptional. They should not be happening all the time, right? Like, this is the definition of exception. This is why it is called an exception. So if you have logs like this, and I'm sure all of us have logs like this is a problem. This means that when you actually look for a problem in your code, when you actually have a production issue, you won't be able to find it because the one exception that matters will be, swallowed by 1 million exceptions that don't actually matter anything. And, you ask the developer, okay, so what is this exception that I see in the log 1,000 times? And he's like, oh, yeah, that's a normal exception. So exceptions are like goto. And all of us know that you should never, ever, 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 and I could go on with this, never use goto, right? Like, it's been removed from all the modern languages on purpose, but instead we have something that is just like goto, only worse. And why is it worse than goto? Because at least with goto, you knew where you were jumping to. You were jumping to some label. When I throw an exception, I have no idea where the control flow would end up, because it's determined dynamically. It depends on who's calling me. Okay, and if we're talking about lambdas, anybody could be calling me. So I don't even know where the code will end up. If that's not bad enough, okay, you have multiple exit points from a function with exceptions, and you don't actually know just by looking at the code where the function will end, because actually it can end anywhere, because almost anything can throw an unchecked exception. So your function can exit from any line of code. Now, sometimes you actually need this, because sometimes you need to use exceptions as a control flow, but more often than not, you just abuse exceptions, and it makes your code very, very problematic to debug, to reason about, and to read. And at least goto was fast, and we'll talk about the performance of exceptions in a second. So no, that's not very good. Let me give you an example of why exceptions are actually so problematic to reason about. So this is a piece of code where we open some SQL connection, and we execute some SQL statement, and when we do commit, an exception is thrown. That happens, okay. And then we catch that exception, we roll back, because this is the reasonable thing to do, and then we close the connection, and another exception is being thrown on the finally block, or maybe in the throws block, in the catch block. Which exception of the two will be propagated upwards? Last one? First one? Last one. Are you all sure about this? Okay, you are correct. It will be the last one, which means two things. First of all, I don't actually know what went wrong in the first place. I can't debug this anymore, because I've lost the original exception. And the second thing is, it's confusing, because not everyone knows this. Okay? Only experienced developers know that the second one will be thrown. So here's another piece of code, this time in Scala. Spot the bug, if you will. Anyone? Yeah? Sorry? Semaphore acquire should be in the try block. So if I move line 1 to line 4, will it be okay? Yeah, you're correct. So the problem is that actually the constructor of worker can actually throw an exception, and so can the logger. Yes, it's rare, but it does happen. It happened to me actually in production and caused a severe problem with a semaphore leak. Okay? But you don't think about this. When you look at constructors, nobody assumes that constructors will throw an exception, right? And yes, of course, this code could have been written in a better way. We should have been using try with resources, or the loan pattern in Scala, blah, 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 yada, yada, yada. Of course, yes. Every code could have been written in a way that will never blow up. Yes, could have, should have, would have. Nice. Cool. But this is how people actually write code. So another example, this time in Java, because this is from a language without checked exceptions. So maybe checked exceptions would have saved us. At least we would have known that an exception can be thrown, right? So this is an actual bug from Solar, okay, a search engine. This is a bug I encountered in production, and I found this bug years ago, blah, blah, blah. This is a very shortened version of the code, okay? If you're interested, go look at the original code. This is an actual bug that happened in production. So we have one thread that goes into the synchronized block and waits on the monitor, on the cache wait. And then we do a bunch of stuff, and we have another thread that is supposed to load the data and release all the threads that are waiting for this data. But an exception is thrown on the constructor of an object, and the other thread never actually notifies the monitor and never releases the threads. And what happened was that we saw a thread leak that was very hard to debug. And this is in a language that has checked exceptions. This was a checked exception. It wasn't an unchecked exception, okay? Just to make it clear, okay? And this happened to people that are very, very good at writing concurrent code. This did not happen to novices. This happened to experienced programmers. Another issue that's very annoying to debug, okay? So you have maybe you process some data, you have some data that you process, and then later on you load it and you do something with it. So in a block that processes data, you read it from source, you process data, you update some tracking table, you save the data, and you mark it as done. Cool. And then in some other place, you load the code and the data and you do something with it. The problem is an exception was thrown, okay, in the first block. Now you would notice that 3 actions actually throw the same type of exception, okay? And what happened was that people, as they do, just pressed Alt-Enter and wrapped the entire thing in a try block, because this is what all of us do. Okay? So they didn't actually handle the granularity of the different exceptions that could happen, because if an exception happened when you update the tracking table, all you need to do is clean up you don't actually need to do anything. If an exception happened when you save or when you mark it's done, you actually have to clean up the update in the tracking table. And that's a very subtle difference. The end result of this was that an exception happened here. It was caught, but it wasn't a big deal. And then much, much later, actually a week later, we had really, really weird exceptions when we read the data, because the data was corrupted. But we lost the context of the error. We could no longer reason about this error because it happened a week apart, and we couldn't understand how the data was corrupted in the first place. And this is actually much more common than you think. Okay? This is a very, very simplified version of such bugs. So the place where you actually catch the error is not necessarily the place where you had the error. And that makes it very, very hard to reason about. Now, of course, this is how this code should have been written. You know, we should have wrapped each line in an individual try block with an individual handler and with an individual finally block that actually does the cleanup properly. Should have, could have, would have. Zombie applications, another very, very fun thing that happens. You would remember that Java, when you have an uncaught exception, kills the thread. But what happens if you actually need a thread? If that thread maybe loads data asynchronously, maybe updates configuration, or maybe updates a piece of data that you cache in memory. But it died, and the rest of the process continues living on. And then you get a zombie application. You have a crippled application that lives on in production. You think everything is OK, but configuration is stale. Some important data is stale. But the application doesn't crash. And again, very hard to debug, very, very annoying. And this is why I think, personally, that the design decision not to crash the application was wrong, but it's debatable. You get the point. So, of course, all of you, when you write code in such a way that handles all exceptions, and you don't write code like this, and you have try blocks after everything, and you do cleanup everywhere, right? Seriously, who does this? We as programmers often treat codes like kids. You know, first of all, my code is not annoying, and it's very clean, and it's well-behaved, blah, blah, blah. The neighbor's code, yeah, he's annoying and dirty and doesn't have any manners, right? No, your kid is just as ugly, your kid is just as annoying, your kid is just as dirty and just as misbehaving. And so is your code, by the way. Newsflash. Also, probably, maybe if you spend more time with your code, and instead of going to the bar and get drunk and read Hacker News or whatever it is that you do, then maybe the code wouldn't be so annoyed and grow up to be an annoying adult. But that's really not the point. That's my life story. But the point is really that writing code is something that we do all the time, and we give our full undivided attention to about 10% of the code we write. The rest of the code that we write, about 90% of it, we just write it, we try to get it over with as fast as possible. Whenever the compiler or the IDE tells us that we haven't handled something, we just press Alt-Enter, and we move on, because this is what we do. Cool. So we need a better way to handle this. Now let's talk about performance of exceptions. So the costs of creating an exception and throwing exceptions are actually divided into a few parts. First of all is the object creation cost, the time it takes to create an object in Java, the time it takes to save the stack in the exception, because exceptions save stack for debugging purposes, the cost of throwing the exception, catching the exception, and unwinding the stack. What is the dominant cost? Anybody wants to take a guess? Saving the stack. Other guesses? Unwinding? Actually, both. Anything that has to do with the stack is very, very expensive. And actually, unwinding is somewhat more expensive, but not by much. So those are results of benchmarks that I've run on my laptops. I encourage you to run your own benchmarks on your own servers and your own laptops, because all benchmarks are a bunch of lies. But you probably already know this. But it's my presentation, so I get to put the numbers on there. So those are my numbers. Object creation takes about 20 nanoseconds on my laptop. For reference, a method call is about 2 nanoseconds. Okay? Saving the stack takes anywhere between 0.1 microseconds to to 1 microsecond if you're talking about a very shallow stack. Throwing the exception takes about 1.5 nanoseconds. That's not a lot, okay, especially if you're not throwing a lot of exceptions. Okay? If you want speed, either don't throw an exception, which is fastest, or just use stackless exceptions. Look it up on the internet if you don't know how to do this, or just to use an exception instance. And actually, there is a JVM JIT optimization that does this for you. If the JIT finds that you're throwing the same exception over and over again, it will cache the exception, it will remove the stack trace from the exception, it will throw the same exception instance over and over again, and it will be extremely fast, as you will see in a second. This is the cost when you're working with diff stack. And as you can see, it's wildly different, okay? When you're working with a stack with 1,000 stack frames, just saving the stack takes about 55 microseconds, which is, like 2 orders of magnitudes higher. Sorry, yeah. When you're talking about really deep stack, it takes about 120 microseconds, the whole thing. Stackless exceptions, okay? They shouldn't take any time. They still take about 80 microseconds, although they don't save the stack. Okay, so that's a big cost. And unwinding the stack takes basically 80 microseconds. So this is why we still have a huge cost, even when we don't have stack in the exception, because unwinding the stack is very, very expensive. Okay? When we have a reuse exception, remember, no object creation, no stack saving, just unwinding the stack, it still takes 4 microseconds, which is a lot for something that should be almost instantly. Okay? You get the point. And even if you catch only after 3 frames, okay, still takes 55 microseconds, which is the cost of saving the stack. Okay? So you could just say, okay, it's unrealistic. Who uses a stack that is 1,000 frames deep? The answer would be all of you. Okay? Because if you've used any type of framework like Spring, or if you used Groovy or JRuby or whatever, you're using very, very deep stacks. Maybe 700 deep, maybe 500 deep, but you are getting to those numbers. Now, if you are throwing a lot of exceptions, you will incur a heavy cost. Okay? Now let's ask ourselves a question. When will we throw a lot of exceptions? Well, we don't do this normally, right? The situation where we will throw a lot of exceptions is when the server has issues, meaning when the server is already stressed. So at exactly the time where we don't need performance issues, we will have them. Because, why not? Why not have a cascading failure? So performance is actually an issue. And I have seen a lot of servers in production that when they have a tiny issue with network or whatever, start throwing tens of thousands of exceptions in a second and basically consume your entire CPU. Yay. So we can do better, and we should do better. We should be using actionable exceptions. A normal exception is not. There is no such thing as a normal exception. If your logs are full of exceptions, and you ask someone, and they tell you, no, it's normal, no, it's not normal, remove this. Exceptions should not be used for normal control flow. If you have an exception that is happening all the time, replace it with data, catch it locally, or do something else that removes this exception. Definitely don't log it. Because the irony of modern days is we have such massive amount of computer power that we actually have enormous machines generating tons of logs, and then we have other machines on the other side, maybe on your cloud vendor, parsing those logs and applying machine learning algorithms to those logs to filter out all the exceptions that we've generated. Yay. So please, 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 don't do this. It will upset Yoda. There are 3 types of error, basically. There are system errors, business errors, and actual exceptions. Okay? So a business error would be something like, I'm trying to make a transaction and maybe give you some money, but I don't have enough money in my bank account, which is something that is reasonable. It can happen. It's part of the normal business flow, and it should not be an exception. This is part of the model that we're dealing with. Okay? Then we have system exceptions, system errors, which are things that can go wrong in the system, but should be expected. For example, permission error when I'm trying to read a file. Okay? It's reasonable, it might happen, I should think about this. This is normal, okay? I've ran out of disk space, I cannot resolve the host. Those are all normal system errors, and they should be handled or caught or reported or whatever, but they shouldn't be an exception, okay? But yes, all of the libraries that we use throw them as exceptions, and that means that we should catch them and deal with them locally. But then we have exceptions. And exceptions are things that we've never ever thought that could happen. For example, I read data from my database and it's corrupted. This should never happen, okay? It's an exception. It doesn't make sense. I should commit suicide and die because there's nothing I can do to fix this. Another example is I try to read your age and you give me a negative age, but I don't get it from the user. That would be a business error. I get it from my own records. This should never happen. It makes no sense. I should die and commit suicide, okay? No, not right now on stage, of course. Come on. Exceptions are basically inconceivable events, things that should never, ever happen, and they indicate that you have a bug, okay? And this is the value of exceptions. They indicate that you have a bug, and they make it very, very easy to debug, because exceptions have a lot of context about bugs, okay? Any exception, every exception, should result in some action. That action can be a change in the code, meaning fixing the bug. It can be a configuration change, or it could be an infrastructure change. Okay? Changing the data, changing the servers, changing the network connections, whatever. But if you have an exception and you're not doing anything with it, then what is the point of having it in the first place? It is just burdening your code with junk. Exceptions are a debugging mechanism. This is why they were created in the first place. This is why we have the cost of saving the stack. We are paying a very, very high cost in performance to get this data, because when you have a bug, that data is invaluable. Okay? It's very valuable. It's worth its weight in gold, and we need this data when we have a bug. Okay? So we need to make sure that we use exceptions to track bugs and not for other purposes. So my personal methodology with exceptions is, first of all, I try to catch them locally if I'm using a library that has exceptions in its API, and do something reasonable with it. Separate the business errors from the system errors and the actual exceptions from everything else. Okay? I try to always install the default Uncaught exception handler, which usually is write the thread dump, write the stack, whatever, write it to a file, and commit suicide, okay? Because this is a reasonable thing to do. I don't want to have stale or corrupt state in my application forever, okay? An exception should always cause a micro reboot, okay? What is a micro reboot? So a full reboot would be ending the process and having something else restarted. A micro reboot would be restarting a thread or restarting an actor, for example. If you're using Akka, this happens almost by default, okay? But basically, you reset the state that presumably is corrupted now, and you carry on, okay? I like closure, because I'm that kind of person. I don't know, I'm weird. So I try to use null punning and monads when I need to write in Scala or Haskell or whatever, because treating exceptions as data actually is much easier and makes more sense for me. But it's a matter of taste, I guess. I try to separate business system and errors and exceptions, because the value of exceptions is when they're not covered with noise. And error log level, that's a very sensitive topic for me. Error log level should be reserved for actual errors. If you see a log that is full of errors, by God, this is not an error, it's normal. Okay, use info or something, I don't know. Just remove it, whatever. So, some food for thought for people that want to dive into this more. There are two interesting methodologies about handling errors in a better way. One is recovery-oriented computing. And the other one is crash-only software. Basically, the idea of crash-only software is that if you have an error, you just die, you just crash. And then you have one recovery path, only one recovery path, which is the application boot. And you can optimize it very heavily because you only have one recovery path. Very interesting methodology. akka is kind of like that in many ways. Recovery-oriented computing puts an emphasis on debuggability and properly handling errors and monitorability and visibility and all that stuff. Again, very interesting. I urge you to go and read about this because, you know, errors are a very unfortunate part of life. So I'm pretty much done. If you have any questions, I will not answer questions about this slide. I don't actually want to talk about this. But if you have any questions, now's a good time. Yeah.
Do you have any opinion when to use checked exceptions and when to use unchecked exceptions when we define them for our purposes?
Personally, I don't like checked exceptions. Most of the languages that I work with don't have checked exceptions. I think that as a general mechanism, they failed. They did not bring the results that we wanted. But some people do see value in them, and I guess it's a matter of taste. Okay, thank you.